Hey guys, welcome back to the Philco 48-1000 restoration project. Here's a progress update. Been making slow but steady progress with the recap. Now a lot of these caps are just simple bypass. All these ones that are 4002 or 4000 picofarad. And in fact, the version that's illustrated in the Sam's Photo Fact, the version that used bumblebee caps for a lot of these paper caps, didn't use bumblebee caps for these. It didn't use paper caps for these. I believe they were either mica or ceramic. And in most sets and later sets, they would have used inexpensive ceramic caps for all these bypass caps because it's not critical. If they're temperature dependent, if the tolerance isn't that great, it's not that big a deal. But in this set, they used all paper caps. So that's why it's about double or triple the normal amount of paper caps. A lot of them are these 4000 picofarad bypass caps. They're scattered all over the place. Alright, so I've been making slow but steady progress replacing those. But the other thing that's slowed me down are resistors. There are a lot of bad resistors, in particular the low valued ones, the sub 100 ohm resistors like the 68 up here. The grid bias resistors, another 68 there. And I'm getting ready to replace this 68. This measures 168. This 120 ohm down here measured over 1000 ohms. So in other words, I'm finding a lot that are way more than double the value they're supposed to be. At least for the lower valued ones. The higher valued ones, like the 470Ks, the 1 megs, are generally not so bad. Now another thing that's annoying is the service info. This is virtually useless for this project because this is for a different chassis revision. I believe there's a code 123 and a code 125. This being the 125, I believe this Sam's is covering the 123. There are a number of differences. One thing that really tripped me up for a while was I wanted to do a power-up of this chassis with the rectifier tubes pulled out, just to check the power transformer. Does this thing turn on? Can I light up the filament juice? Are the secondary voltages okay? I rigged up a power cord. Now that's another thing that threw me off a little bit. It's polarized and the pin spacing is not normal. But I've been working on one of Zenith portholes lately, and it turns out they use the same interlock. So I borrowed one from a Zenith porthole set and it plugged right in. Hooked it up to my PR57, turned it on, nothing happened. Checked the continuity on the power switch and it was a little flaky, but by working the switch back and forth a dozen times, that seemed to fix that. Still was getting nothing. And I traced out the wiring. It turns out that one side of this AC cord goes right to this plug. And this plug goes to the yoke. Turns out there's a safety interlock. So if you disconnect this, the set will not turn on. I bypassed that with this yellow wire here. I'll disconnect it later on, but for now I wanted to be able to turn this on, and I did. And the tube's lit up, and the secondary voltage got about 700 volts on the main B plus secondary, which sounds right to me. So we're good there. There are some bypass caps across the AC line. I disconnected them. I need to replace these with safety caps. So continued on. So I mentioned the service info wasn't very handy. Another thing that really tripped me up. Oh, well, yeah, sorry. Because the version that's shown in the Sam's doesn't show that interlock. It just shows the plug and a power switch going right to the primary. That's not how this set's wired up. Another thing that confused me was working on the audio first and second IF stages. Very different. This shows what do we got? 7H7 tubes. I found 7W7 tubes, which have, I think, the same pinout. One is a semi-remote cutoff, and the other is a remote cutoff type tube. So they're not entirely dissimilar, but it's not just that. The the component values around those sockets was quite different, so I was really scratching my head until I referred back to the rider's service info in volume 1. Now, I had printed out some stuff from the riders, but this was also showing 7H7s in the sound IF. But I kept digging and I found that I realized that this was actually code 122, so I had printed out the wrong schematic. Once I got back on track and found the schematic for code 125 and riders, I think it's volume 1, things started to make more sense, including this. There is a solid-state diode in there, a 1N34, which is also not shown in the code 122. That, I think, is for DC restoration. In the schematic, they actually label what it's for, but I do believe that's what they added that for. So, a little bit more confident now that I found the right schematic and things are making sense. Go on, I continue on with that. Still quite a bit to do. I've got all this section to do and all this. That's the first and final audio output stages down in here, and I believe we have some sweep circuits up in here. Oh yeah, and the horizontal oscillator, horizontal output, and damper tube are right on top of this stuff. Just finished reviewing all the tubes, cleaning them up a bit to discover one of the 6AG5s in the tuner has gone to air, so I just removed it. I have it plugged into a power source now. That Zenith salvage cheater cord. I'm going to turn it on here so you can see what it looks like with the tubes lit up. Remember, no rectifier tubes installed, so no B+, just filament juice. Isn't that pretty? Fortunately, the way the loctals are made with the getter on the top, you can't see the filaments very well in them, but they are all lighting up. That being the audio output tube. These guys you can hardly see. But anyways, so that is all good. I also put a AC voltmeter across the two rectifier tube sockets. I got 700 volts AC with half-wave rectifier. It'd be 300 volts AC after it gets rectified and filtered and all that. It'd be, I don't know, about 300 volts DC, probably a little less, and that is what it should be. So I think we are in pretty good shape. Continuing on in the fine tradition of overkill, I used some Bondo glazing compound to fill in the pits left after I removed the corrosion. That's set up. Now I'm going to put on a little silver metallic paint. I'll see which looks better. Either this Rust-Oleum enamel paint, or I've got this appliance epoxy. Both I've used before with pretty good results. I'm just going to do a little test to see which looks better. I'll spray it into the cap and just brush it on. A little corrosion here I still need to remove. Earlier I'd mentioned some scrubbing brushes, but I don't know if I actually showed them. I'm talking about these things, which have fiberglass fibers in the end, and you can screw, or twist rather, an end on these in like a mechanical pencil. The fibers come out longer and longer, and you can go over metal. Used for jewelry, cleaning coins. You can get these in different fiber hardnesses, thicknesses. And they do a really nice job of, well, if you get the right bristles, cleaning up the metal, polishing the metal, removing surface corrosion and gunk without scratching it up. Close enough. I had also removed the filter choke and took the cover of it off, and it has also been repainted. But before we install that, let's get these new capacitors installed and wired up. Yeah, I like that a lot better. I just put some black Artist enamel water-based paint on my fingertip and rubbed over it a little bit. Also makes the Philco numbers stand out, pop a little bit, but yeah, it was a little too stark the way it was before. Alright, let's get those new caps installed. We're getting close, guys. The new electrolytics have been installed and wired up. Leaves these two guys. I'm going to tack on replacements down below and leave the originals disconnected. I have one paper cap up here to replace. I removed the cover over the flyback horizontal output circuitry and did some cleaning and examination. Cleaned up the tubes. We had a 6BG6 horizontal output tube, a 6AS7 tube for the damper, 1B3 high voltage rectifier tube, and there's our 500 picofarad doorknob ceramic capacitor for filtering the high voltage, and our flyback. Now this flyback is a little bit unusual. Most are made up of compressed powdered iron, a special formulation. Here's one from a Zenith, similar to a ferrite rod in an AM radio. But this is laminated. And I've heard they had trouble in the early days about making laminated transformers for the flyback because these run at high frequency. Now this is laminated, but it runs at 60 hertz right off the line. But this is running at almost 16 kilohertz. So whatever these plates are made out of, it's going to be something a little unusual. They're very thin. I wasn't sure at first if they even were individual plates, but they are. I feel to run my finger over it. But what are they made of? I don't know. But it's going to be somewhat unusual formulation of iron, or if it even is iron, I imagine. Now I was curious. I looked up this part number in a substitution guide from Thord Arson to see what replacement they offered, if any, and it's a Fly 1, which is the type used at RCA and Admiral and many, many others from the same era, which uses a compressed powdered iron core. But they look quite a bit different, and it would mount very differently. But this construction style appears to be somewhat unique to Philco. And we have to hope it's good. But I guess it's somewhat reassuring to know that in a worst case scenario, if it's open or it goes open, I do have some spare Fly 1s. That's a pretty common flyback, actually, if I had to. Oh, what else? Oh, you would need to replace this one bad tube. I haven't tested any of the tubes. I cleaned them up. I visually examined them. That one was clearly gone to air, so I took it out. We'll get around to testing them as we proceed. I did print out service info, enlarge some of it, like here's the horizontal oscillator. Some of these other circuits they broke down into individual sections, and they have voltage key voltages throughout. So that should aid us in our first power up. So what's left to do is put the rectifier tubes back in, reinstall the filter choke, and as I mentioned, replace these last few capacitors. And I think we'll be ready for a controlled power up. Now I'll also need to clear the decks a little bit because I need to get the CRT and yoke and harness and all that up on the workbench, and it plugs in down here. There's also this connector that's been cut off. I think that is the audio output. Seems a little bit of an odd place to put it right next to the high voltage stuff because the audio amp is actually over here, and that's the audio output transformer. So I'll have to double check that because there's also what looks to be a connector over here. It could be an alignment aid, or maybe that is the sound output. Oh wait, no, here it is. Here's the speaker output. Okay, now I'm definitely curious. Maybe that's the antenna. RF input. This is sort of in line with the tuner, so I can see that making some sense. Let's take a gander underneath, see what that goes to. Oh yeah, that is most definitely the antenna input, but notice there are two twin leads coming out of it going over to the tuner. I suspect one is for high band and one is for low band VHF reception. Well, I guess the time has come to give this a try now. I admit I am a bit less confident than I usually am, because I haven't worked on one of these chassis before or anything quite like it before, and I did a lot of work on it. Yes, we did a power up and got the tube filaments to light up early on, and I checked the secondary voltages, but a lot's been done. So, and I haven't checked the continuity on everything. I did it in the horizontal blocking oscillator transformer that has continuity. Filter choke does. Like I said, we checked the power transformer, but there's the vertical output transformer, vertical blocking oscillator transformer, and of course the flyback. So, well, without further ado, let's plug this in and turn it on here. Let's put this into current mode, turn it down a bit, and here we go. Alright, that's good. I'm going to turn it off because I dim the lights a bit so I can see better what's going on. So it came on, the filaments were starting to light up. Let's do it again. I'll grab a fluorescent bulb too. Screw to high voltage check. Keep my eye on that current. If it shoots up, I'll hit the switch, or the circuit breaker will pop in this thing. And no high voltage. Okay, well, I guess things could be worse. I'm kind of thinking, I don't know if we've got plate supply going to everything, so I need to find a convenient spot to check for B+. That's easy to do on the top of the chassis, and this thing is a beast to tip on its side. I intentionally left the cover off the high voltage circuit so I could see what was going on there. Let's see. I'll do that again. Usually you can tell when the B+ kicks in because the current jaw changes. Okay, it is going up. You don't hear that characteristic sing. A little blue glow on the side of the 6BG6, but that's just electrons hitting the glass. I haven't checked out the tubes. I mean, it's a million things that could be going on. I wasn't exactly expecting this to just work perfectly first power up, but I'll probably get something. I'll be honest, I was hoping a little bit luckier than that, because I don't think it's going to be a very easy chassis to troubleshoot. They're again wieldy, especially with having to plug in the CRT harness. Anyways, let's put this in AC mode. I got a high voltage probe here. It's weird. When I first go up to it, it's shooting up to a few hundred volts, but when I keep it on there, it drops down to nothing. Try DC mode. 245 volts, so yeah, there is a B+ supply. It seems a little low. I think the oscillator's not running. One final word. The horizontal output tube is getting pretty hot. It's not red plating, but it's toasty, so another good indicator that the horizontal oscillator is not running.